Hello and welcome to the first part of this mini course about Kafka, Karafka and how to use these tools in your Rails applications. The best way to start it would be to make an introduction to the Kafka itself, as this is the most essential piece we are going to deal with. This part is mostly dedicated to either developers who have little idea what Kafka is, or they already know something but they might be missing a bigger picture, so if you have some experience with Kafka you might not benefit from that much. But still, you are more than welcome to watch it, so let's start. So what is Kafka? A popular definition you might find out there is that it's a distributed event streaming platform that implements a publish-subscribe model. So besides this fancy distributed event streaming platform, it sounds pretty much like a definition of a standard message queue. So what makes Kafka so different and unique? What's all the fuss about? There are two primary interrelated things that make the biggest difference, and the rest is just consequences of these two. The first thing is that events are stored in a persistent and durable append-only logs. This is not an ephemeral storage. The messages are not gone after they are consumed. They might be even stored forever, so this is almost a database-like storage. And the second thing is that it's a dump broker smart consumer model, which is contrary to most of message queues that implement smart broker dump consumer model. For example, in RabbitMQ, thanks to the smart broker, you can have a pretty complex routing, which you cannot really have in Kafka. However, this is the beauty of Kafka, that consumers are responsible for all the heavy stuff, like managing their own state, and here, for example, storing offsets of events they have already consumed. It brings some unique opportunities along with durable storage. And Kafka is also highly performant and scalable. It's not like other message queues don't scale, but Kafka is almost legendary in that regard. If it works for LinkedIn and things like activity tracking on their side, it's most likely to be okay for your application. So, is it a message queue or a persistent storage? Well, it's a message queue with a persistent storage, so kind of a hybrid system. It's important to keep in mind that messages are not removed from log, or actually topics and partitions, which are the proper terms, after they are consumed. Consuming messages has nothing to do with deleting messages. Rather, deleting messages is controlled via retention policy, which can be time-based and size-based. You can configure Kafka to store messages, for example, from the last week, so all older messages will be dropped. Or you can also configure it to store, for example, up to 1 terabyte of messages, and everything beyond that limit will get removed. Or you can even store things indefinitely. As I mentioned before, messages, or events if you like, are stored in topics that can be partitioned, so the partitions of the topic are these append-only logs. Messages within a topic partition can be identified by offsets, which are like array indexes, which is actually a pretty good way of imagining how messages are stored and how they can be accessed, but the proper visualization will make a better job here. So here's an example topic with 3 partitions. Each message within a partition is identified by an offset, and the offsets from partitions are independent from each other. The processing of the messages in the partitions by the consumer starts from the beginning, at least usually, it can be configured though, and then it goes to the right, so from 1 to 10 and so forth. If we're already on processing or consuming the messages, then the right question to ask would be about semantics and practical considerations. For the great majority of the use cases, we choose between at most once and at least once delivery. It's possible to have exactly once delivery, but it's rare and it involves a significant overhead, so it might not be necessarily even worth it, as at least once delivery might be a better choice, so let's focus on the first two. In at most once delivery, the message will be processed either 0 times or once. In that case, consumers won't be committing the processed offset after a specified interval, as this would imply committing after processing. Rather, it will be auto-committed after fetching it, but whether consumer has indeed handled it properly or not is a different question. The semantics might make sense if you can afford to lose some data, and for example, 99.9% of the consumed messages are fine and you care about the maximum possible throughput. If you can't afford to lose messages though, you should definitely stick to at least once delivery, where a message will be processed either once or more times, and the fact that it's been processed will be committed after a certain interval. This requires idempotency on the consumer side to make sure that processing the same message again won't trigger any unexpected side effects. Also, when we are talking about partitions, we cannot forget about an awesome feature which is log compaction. When publishing messages to Kafka, you can specify a message key. So imagine you are publishing projections of some entity or domain-driven design like aggregate, like an invoice. And you want to store only latest projection of each invoice. So no need to keep any intermediate projections in that case. If you want to achieve that, you can enable log compaction, and for each given key, for example, invoice/1, only the last message will be preserved in the given partition in a topic. Partitions serve as a parallelization unit, so with more partitions you can achieve a higher throughput, but you can also achieve having more problems, like potentially increase unavailability if something goes wrong, or latency. Choosing the right number of partitions is not really an obvious thing, and I'm going to cover it in the part about advanced Kafka. But it's worth keeping in mind that within a single consumer group, you can only have one consumer assigned to a given partition, which is a consequence of the design. Otherwise, it would be very difficult, if even reasonably possible, to ensure messages are consumed one by one. So if you have 50 partitions, then the most you can get is having 50 consumers, and each one would be assigned to a separate partition. Anything more than this won't make any impact, as there would be no more free partitions, basically. And what's actually a consumer group? To put it simply, it's a way of grouping consumers to either have messages consumed separately by some sort of unit, for example, an application. If you have 3 applications and each of them would be representing a separate consumer group, each application is going to process all the messages. So in total, messages would be processed 3 times. But if these 3 applications were in a single consumer group, we would have competing model, and perhaps different applications would be handling different partitions in the same topic, which in most cases won't make much sense. In such case, all messages in total will be consumed once. And something very important to keep in mind, messages are ordered only in a given partition in a topic. So if causality is critical to you, you have to make sure that you use proper partition keys when publishing things from the same scope, or maybe let's call it tenant, like account or user model. Just to give an example about causality and ordering, it would probably make sense to first have the consumer process the message about invoice being created and then about being paid, rather than the other way around, and for that they need to be in the same partition. Based on what we've covered, it's clear that RabbitMQ and Kafka are 2 very different things, and something worth repeating, as it's a very common question whether you should choose one over another, or even which one is better. But the real answer is that those are very different things, and one is not better than another in general. One might be just better for a different purpose. RabbitMQ is a smart broker dump consumer type of system, and its routing system is really smart, and there is nothing like this in Kafka. In general, Rabbit is a standard message queue. It doesn't have a persistent and durable storage. Kafka is almost a hybrid of a message queue and the storage, and the responsibilities for proper behavior are pushed to consumers. So let's summarize the killer features of Kafka. Definitely its performance, ready for LinkedIn-alike scale. Durable storage, which is quite unique, although there are other systems that have this implemented, like AWS Kinesis. The consequence of the design is ability to replay past events, even indefinitely, which might be very useful, especially when a new consumer group joins the system and for some reason it needs to process past events. Log compaction is awesome for saving space and not processing something that might not be useful for the consumers. What is also interesting is that Kafka can be a part of ecosystems that can be easily extended with tools like Kafka Streams, Apache Samsa, Spark, Flink, that will give the possibility to perform operations on streams. You can also have some machine learning on top of this and do some really complex stuff. It's really definitely worth exploring these systems further, as they have really a lot of capabilities. So to summarize, what would be the appropriate use cases for Kafka? A standard one is a publish-subscribe system for microservices architecture to make apps talk to each other via events. Another one would be activity tracking, which is like LinkedIn use case. Metrics and analytics for your apps and server components, which is like activity tracking but on the infra level. Stream processing as an alternative to batch processing, especially with the tools I mentioned, which is Samsa, Spark, Flink. You could actually use Kafka for event sourcing. I don't think it's widely used for that purpose, or at least I'm not aware of it, but it's definitely doable. You can also go pretty crazy and perhaps do something like cross-database replication if you really need to do it for some reason. Maybe Postgres MySQL wouldn't be a fancy example, but Postgres MongoDB is an interesting case for sure if this is something you would even need. So thanks for your attention. I hope you have a better understanding now what Kafka is and how it works. And see you in the next part where I'm going to cover some practical considerations regarding modeling topics and publishing messages.